Dimensional analysis is one of the most useful math skills that you can learn. It is useful to help convert between units. If we look at the example that I wrote, it says how many hours are in 3 days. So we're looking to go between hours and days, and we can easily do that using something that's known as a conversion factor. A conversion factor is used to change one unit into another, and we use what we know about how the units relate to each other. So we know that in every one day, there are 24 hours. This is the conversion factor. Okay, so what do? We take the words how many hours are in 3 days and we set up some type of math equation. So the way that I do it is how many hours are in 3 days. So the first thing I do is set up this equation. And now I can use the conversion factor in order to convert. I do that by taking advantage of the fact that in math, units will cancel from each other if they are placed diagonal from each other, numerator and denominator. So here I have days on top, and I'm going to put days on the bottom so that days will cancel days. And on the top, I'm going to put hours. Now I'll go back in and I'll put my values in. So I know in every one day, there are 24 hours. Okay, so my days I have canceled out, and I need hours. Here are the hours. I'm ready to calculate. Everything on the top gets multiplied, and everything in the denominator on the bottom gets divided. So we can say 3 times 24, and that will give us an answer of 72 hours. We are going to look at a few examples of how to practice doing this. Let's see. It's useful for these calculations that you've been finding in stoichiometry to convert between grams and moles, grams to moles, and from moles to grams. And then we're going to look at moles to moles. After we get some practice doing this, we can look at some questions that require you to convert a few times to get the units you want. So here is a worksheet that was given in class on Friday, and I want to go through it now and we could practice together, okay? This worksheet can easily be found in our Google Classroom. So the first thing I'm going to do is I'm going to read the question and I'm going to change the question into my equation, the math equation that I need. The question says, calculate the number of moles of magnesium hydroxide in an 8.4 gram sample. So I'm looking to find moles in a size sample, and the conversion factor that I'm given is this molar mass right here. So how many moles are in an 8.4 gram sample? Okay, that's the setup. I'm now going to use the conversion factor that I have. I put grams on the bottom and moles on top. Grams will cancel grams. Okay, so I know that 58.3 grams are in every 1 mole because that's what this molar mass tells me. Okay? I need moles, and now I have them. Now I can calculate. Everything on the top gets multiplied. Everything on the bottom gets divided. So 8.4 times 1 is 8.4. And 8.4 divided by 58.3 is 0.144. And the unit is moles. Okay, let's take a look at the next one. it says calculate the number of moles. So once again, we're going to be finding moles present in 11 grams. Okay, here is the conversion factor over here. Okay, so how many moles are in 11 grams? Grams need to cancel, so I'll put grams on the bottom, and on the top, I'll put moles. I know from this conversion factor, there are 44 grams in every 1 mole. Okay, we need moles, got moles. Everything on the top gets multiplied, everything on the bottom divided. 11 times 1 is 11, and 11 divided by 44, the answer is 0.25 moles. Let's look at the next one. The next one is a little bit different, but we're going to approach it the same way. This one is asking, what is the mass? What is the mass? So the mass means we're looking for grams. Okay, so how many grams is equal to 4.76 moles? Okay, here is the conversion factor. Moles will go on the bottom because now I have to cancel moles. And this time, grams will go on the top. I have 164 grams for every 1 mole. Okay, so we multiply. We say 4.76 times 164. And we get an answer of 780.64, and the unit is grams. I'll switch my tool. Okay. So here, instead of going from moles to grams, we went from grams to moles, okay? Let's look at the last one on this page. It says determine the mass. So once again, we're looking for grams. How many grams are in 5.24 moles? Okay. And the conversion factor is here. Moles go on the bottom, so we can cancel moles. Grams will go on the top. Okay, so we know 84.2 grams are in every 1 mole. We can go ahead and calculate 5.2 times 84.2, and that's equal to 437.84 units grams. Okay. It's important to keep our units diagonal from each other. It's important that we set these questions up correctly. Another common thing that I see is that sometimes students, when we're looking at this conversion factor, let's say the grams and moles, we have to make sure that we are putting 1 mole for every certain amount of grams and not the other way around. This would be much different if we wrote this way. If we put 84.2 moles for 1 gram. It's important that we know exactly how these conversion factors are working. So this would be wrong, okay? I want to now build on this. So if we look, let's look at this question number 5, and then we will go on to the next set of questions and we'll build upon this skill a little bit. So I'm first going to identify what's given to me and what's being asked of me. I'm being asked about the total number of moles. So I'm looking for moles. How many moles? And I'm given a 52 gram sample. So how many moles in a 52 gram sample? I could write sample. Okay. conversion factor is here. I have to put grams on the bottom so grams can cancel grams. And I put moles on the top. And I'll go back and put the values in. I know that there are 65 grams for every 1 mole. All right, now we can calculate. Everything on the top gets multiplied. 52 times 1 is 52. And 52 divided by 65 gives me 0.8, and the unit is mole. Okay, and that's the answer to this one. Now, let's look at this next set of questions. Here, I'm not given the molar mass. I don't have a conversion factor. So I'm going to have to find molar masses and use what I find as my conversion factor. I put these squares from the periodic table, from your reference table, I put them on the side to help us find quickly the molar masses. So the first thing I'm going to do is determine the molar mass of my compounds. Here I have a compound LIF, and I need to find the molar mass. In order to do that, I'm going to use the atomic masses. Okay, so lithium has an atomic mass of 6.941. I'm just going to round that to 7. And I have fluorine. It's not showing up on this page, but I have the periodic table in front of me. It has an atomic mass of approximately 19. So the molar mass are these numbers added together. So 7 plus 19 gives me 26 grams per mole. This is the conversion factor I'm going to use. Now let's set up the equation. It says, what is the total number of moles in 39 grams? So how many moles are in 39 grams? Okay, and I have the conversion factor. Grams go on bottom and will cancel, and moles will go on top. I have 26 grams for every 1 mole. Okay, so I'll calculate, and I have 39 times 1 is 39, and 39 divided by 26 gives me an answer of 1.5, and the unit is moles. Okay, next one. I have to first find the molar mass so I can use it as a conversion factor. Carbon, I have 2 carbons present. I have 5 and 1 more. Hydrogen, 5 and 1 more. That's a total of 6 H's. And I have 1 oxygen. So we're going to find the atomic masses for all of these elements present in the compound. And then I'm going to add them up to get the molar mass. So each carbon is about 12, and I have 2 of them. So 12 times 2 is 24. Hydrogen is about 1, and I have 6 of them. 6 times 1 is 6. And oxygen is about 16, and there's only 1 of them. So the total sum for this compound is 46 grams per mole. This is the conversion factor that I'm going to use. Okay, so back to the question. What is the total number of moles contained in 115 grams? Let's set that up. How many moles are equal to 115 grams? Okay, grams on the bottom, moles on the top. I have 46 grams, grams cancel gram, for every 1 mole. And we're going to calculate. Everything on top, multiply. Everything on the bottom, divide. 115 times 1 is 115. 115 divided by 46 gives me 2.5. And we have to put our unit, which is mole. Okay. Last question on this page. I need to first find the molar mass of SO2. Okay, so S, I'm using my periodic table. S is about 32. and I have 2 oxygens. Each of them are 16. 16 times 2 is 32. I add this up. I have 64 grams per mole. Here's the conversion factor. Now let's set up the equation. What is the total mass in grams? So I'm looking for grams this time. How many grams are in 0.75 moles? Okay. Now this time, moles must go on the bottom and grams will go on the top. I need moles to cancel moles so that I can have the grams that I need. Okay. There are 64 grams in every 1 mole. Okay, now we can calculate. Everything on the top gets multiplied. 0.75 times 64 equals 48, and the unit is grams. This is the answer to this question. Okay, let's look at these questions. First thing we do is find the molar mass. I have C, one of them, 5 H's, and 1 Cl. Carbon is 12. Hydrogen is 1, so 1 times 5 is 5. And chlorine is about 35. I'm going to add these up. I have 52 grams per mole. Okay. Now let's turn the words into an equation. What is the total number of moles? So how many moles are in 80 grams? Okay. It's also important that we remember that we are saying equals to this and not the conversion factor. I sometimes see students putting how many moles in 52 grams or in the molar mass. It's important to keep our conversion factor as a conversion factor, and it's not what we're looking for. It's not what we're trying to identify, okay? So how many moles are in 80 grams? And now let's use the conversion factor from the molar mass. I have 52 grams, grams cancel gram, in every 1 mole. Okay, math time in the calculator. 80 times 1 is 80, and 80 divided by 52 is equal to about 1.54 moles. Okay, last question. What is the mass? That means how many grams? How many grams are in 4.5 grams? 4.5 moles. Okay, we have to find our molar mass for the conversion factor. I have 3 magnesium. I have 2P, right? Because this subscript tells me that I have 2P, and I have 4 times 2, I have 8 oxygens, okay? So magnesium. Each magnesium is 24. I have 3 of them. Each phosphorus is 31. I have 2 of them. Each oxygen is 16, and I have 8 of them. I'm just going to plug these into the calculator and then total them up. So 24 times 3 is equal to 72. 31 times 2 is equal to 62. And 16 times 8 is equal to 144. Now let's total these up. 144 plus 62 plus 72 is equal to 278 grams per mole. This is the conversion factor. Now we can go ahead and put that in. I need moles to cancel moles, so I put it on the bottom. And I put grams, the unit I'm looking for, on top. And I know that I have 278 grams for every 1 mole. And now I'll calculate. 4.5 times 278 gives me a total of 1,250 51 and the unit is grams. Okay.